Alright, today we're going to be taking a look at this really cheap hot air station. This is the Fita, I'm not even sure how you pronounce that, but it's one of the 858D knockoffs. And these are pretty common nowadays. They're real simple. You've just got an up and a down for your temperature control, and then you got this potentiometer here for the airflow control, on-off switch in the front. The cable is permanently tied into the station that goes out to the handle here. And that's probably partially because this cable has 120 volts running through it, so putting a connector on this isn't always the greatest of ideas. We have this little stand that can be moved to either side of the unit. On the back we have a banana jack for grounding and standard IEC connector, which has a fuse in it. And we have some ratings there. Fuse is apparently 6 amps. Power consumption is 700 watts. And really that's about all there is to this unit. The handle is also pretty simple. It's made out of plastic. It's got a fan back here which sucks air in through this side, I believe. And then we've got a heating element up here. And you can pull these nozzles off. Comes with 3 nozzles. They're just real simple round ones. 3 different sizes is all that is. And that's the third one, of course. And you can't really see too much from the end of the handle there. That's just where the air comes out. And the nozzle just screws on like so. And this one, like a lot of the common ones, will have a reed switch inside of this handle somewhere. And then there's a magnet somewhere in this guy. So when you put this down, the station recognizes that and it will turn the heating element off. So I paid $39.99 for this thing from Amazon, and that even includes the shipping. And you can get them even cheaper than that if you want to go buy them from eBay. Anyhow, it also comes with the power cord, of course, so we'll go ahead and plug it in. So I'm curious about a couple things with this guy. One is, how accurate is this temperature control? I'm not expecting too much. And the other thing is, how much power does this thing actually use? So we've got a watt meter there, and we've got a thermocouple here. So we'll put this in there and we'll set this on degrees Celsius. And we'll just blow air across that thermocouple. It's probably not going to be the most accurate way to do it, but we're going to try it. And I'll move this so the camera can actually see the watt meter, hopefully. So we're going to turn this on. We'll go ahead and set the temperature all the way up to start with, just to try to get an idea of how much power this thing actually pulls. And we'll set the airflow all the way to the max as well. Right now we're just sitting here in standby. We're taking 2.9 watts, which is just running the control circuitry, of course. And if we lift the handle out, that should jump up 680 watts, 675. Yeah, so it's pulling pretty close to the 700 watts that it claims to on the back of the unit. And that's 450 degrees there. You see our wattage has come down a little ways. This is quite a bit like my Heiko soldering iron, in that if you look at the front of it here, I don't know how well the camera's picking that up, but there's a little flashing indicator right there, the last decimal point on that LED display. That is showing you that your heating element is turned on. And of course, if I set that back down in there, you see our temperature starts to drop. And the fan continues to run to cool the heating element off so it doesn't get heat soaked and burn itself out. You always want to let these things cool off before you go and flip the switch, because of course this thing's measuring the air temperature coming out of the nozzle, not necessarily the temperature of the heating element itself. So if you just turn the power off, that heating element's going to be really hot still, and that can potentially do damage to it if you do it enough times. So now I'm going to go ahead and take our temperature back down to the minimum set point, which is 100 degrees Celsius, and we'll just set our airflow somewhere around the middle, pull it off of here, and we'll blow it across this thermocouple, which is probably not really the best way to measure the accuracy of something like this, but we're going to try it anyway. And we're at 106, 108, still going up a little bit. 110 degrees looks like is what we're going to sit at, which is reasonably accurate. I'll go ahead and set it to 200 degrees and we'll see if it overshoots too. So there's set point of 200, so this should start coming up. Now I will note when you start pressing those buttons, it seems like it shuts the heating element off. And there we go, it actually came right up to 200. It didn't look like it overshot at all. We're kind of creeping up past 200 right now. 204. We'll set it to 250. My thermocouples are rated for 300, so set it for 250. Comes right up to 252, and then it's backing off just a little bit. But one thing that seems to be real common on these units is the fact that when you put the handle down, it really doesn't seem to like to turn itself off. You notice I put it down the last time, it's still running. Still says 250 degrees on the display. It has not turned off yet. So you kind of have to fiddle with it until it finds a spot that it likes. There we go. And I will note that the temperature display when it's cooling off likes to jump around a lot. So you'll see it goes 200, then it goes below 200, then it'll eventually jump back up again. So it really does kind of surprise me that the temperature, at least according to this, is reasonably accurate, because that display seems to jump around all over the place. And then when it does finally cool off enough to the point where it shuts the fan down, the display does the 3 little dashes like that. So anyway, we can go ahead and turn it off now, and we'll go ahead and tear this thing apart and see what makes it tick. I'm not expecting to find a whole lot in here. This side of the unit has a warranty void if removed sticker, so we're going to start here. It looks like I can just take out 4 screws around the outside of this plastic. So there is the back opened up. And we've got 3 wires coming off of here. These will be line, neutral, and ground, presumably. If you ask me, all the wires that are in this thing are pretty thin looking, especially the main cable here. And I have noticed that this cable gets kind of warm if you use it for a long time. Not like concerningly warm or anything, but just noticeably warmer than ambient temperature. Yes, it is nice that these are actually terminated and you can pull them off of here. Well, in theory, you can pull them off of here. So if we take a look, we got our ground. We've got one of these will be line, one of them will be neutral. That's running through a fuse. And then we have this wonderful little, it's probably a 1 mega ohm resistor, which is going between the ground and this lug up here. You notice none of that's soldered. That's just kind of twisted on right here. And then I think if we pull this connector off, I bet you that resistor just kind of wrapped around here. So yeah. So that resistor is just kind of there. So I'm not sure I would trust the grounding strap on this to actually give you any ESD protection, but it's on there. It might be worth coming in here and soldering this on at least. I'm not really sure you want to solder the a connection up here, but go ahead and take a look down inside this guy. Probably not going to be a whole lot in here. So we've got a little transformer, and that'll probably be putting out either 12 or 24 volts, just enough to run the control circuitry. So yeah, down in there, that's just a real simple single-sided circuit board. And it's got connectors on it for some of these things, like the power going in and all that. You got a little socketed chip down in there, actually. I'm surprised they bothered to spend the money on socketing that chip. Let's see if we can't get our front panel off and take a look at that circuit board. There's probably not going to be much there. All you're going to have really is a something to control a triac, and then the triac will be turning on and off the heating element in here. And the fan is also going to have a separate control, I suppose. I also don't know if the tip of this is grounded. Maybe that's something we should check out too. Alright, so here's what the board looks like. This is going to be kind of tricky to film because it's at a weird angle and there's not much light on it, so I apologize that the video quality isn't the greatest on this. But there's not a whole lot on here. You've got this completely unmarked microcontroller thing, which is sitting in the socket. You've got a little 8-pin chip, which is probably, I'm not really sure what that's doing. That might be for the temperature probe out in the handle or something like that. You've got this guy, which is a tip 122 transistor. This thing over here is just an LM7805 voltage regulator. And this over here is a BT16A triac. And then this is presumably something to do, that might be like an opto coupler or something for the triac. Capacitor up here. And then all these wires are going out to the handles. So there's quite a bit of stuff going on in the handle, really. And I mentioned earlier that the wires in the handle get a little bit warm when you're running it. And you can kind of see why. This red wire and this black wire appear to be the only wires that are carrying current out to the heating element. And these are super thin. These are probably 22 or 24 gauge wire. And then this green wire is running into the ground lug back in there. So the tip of this guy is going to be grounded, presumably, which is a good thing. And then we've got blue and orange are probably the fan wires. And then these three are going to be whatever thermistor or thermal couple that they've got up in the tip of the unit, and probably also the switch to detect when it's in the cradle. This connector has the output wires of the transformer. Looks like that may have a few different output voltages potentially, because there's 4 different wires coming off of that. And then you've got a bridge rectifier, presumably, but I see a total of 6 diodes there, so that might make sense given the fact that it looks like there's multiple voltages coming off that transformer. I'm guessing the tip 122 transistor over here is responsible for controlling the fan speed. And then, of course, the triac's going to be controlling the heater element. And there's really not a whole lot else on here. There's a few capacitors and things, but anyway, the interesting bit, which is this chip has a number, well, it just doesn't have a number at all. It doesn't look like it's been scrubbed off or anything. It just looks like it never had one put on it. But that's kind of expected. It's just going to be some form of microcontroller. And you can tell it's built down to a price. It's just a simple single-sided circuit board. It's all through hole. So far, the 2 things I don't like are the really thin wires right here that are going out to the heating element, and of course that bad ground connection in the back. But of course that's only really there for ESD protection anyway, and I probably won't really ever use that, so I'm not too concerned about that. But anyway, let me put this back together and we'll take a look inside the handle and see what's in there. And I actually just realized this because of course it had this plastic surround over it, but the front plate of this actually has a plastic peel-off thing. I noticed it was wrinkled up around that power switch, but of course, probably not going to be able to get this off because everything's put on top of it. So that's kind of annoying. Just do the best we can getting this off, I guess. We should be able to pull this knob off of here, I think. Yeah, there's a set screw in the back there, it looks like, unless it just slides off, which it does. So yeah, it actually has a plastic covering over it, which is slightly annoying because there's no way that you could peel that off without taking that front piece off of it. But anyhow, I'll go ahead and get this thing put back together. Alright, I don't think this will be too difficult to get open. This guy should unscrew from here, I think. Not sure if this gives you access to anything, but it's got to come off to get that case apart. We can pop our tip off too, but I don't think it's really going to make a difference. And then it looks like there's just 2 screws back here that are going to come out. Just like so. There's the fan. Yeah, so that's relatively simple. It's just got a little squirrel cage fan soldered onto a couple of the pads there. Here's the brand of the fan. That is a 24 volt, 120 milliamp guy. We have a ground wire, which is connected to literally nothing. And you'll notice that we have the green wire right here is soldered down to the ground pad, and then nothing is soldered over to here. So that's not great. And then we've got, it's like, yep, the blue and orange wires there going into the fan. And then we've got a few more wires coming over here. See the heating element, and then there's the reed switch right there. It looks like it's just hot glued down, and that's what's sensing whether or not that it's in the cradle or not. Looks like the heating element's got 4 wires going into it. 2 will be power and 2 will be a thermistor or a thermal couple, something along those lines. So yeah, the ground isn't hooked up on the heating element whatsoever, which is a little bit scary. So let's just pull out a meter real quick and check for continuity here. And I'm gonna go from the ground pin on the back of the IEC connector up to this ground pad on the circuit board. So we've got ground all the way up through there, and then they don't bother to connect it to the heating element itself. So they've gone through all the effort to connect the ground from the power outlet all the way up to here, but they just neglected to solder a wire on here and run it into this connector, which is kind of unfortunate. And while we're in here, we can go ahead and see if this connector is actually hooked up to anything. Not that I would trust it. It should be a 1 meg resistor probably. Oh no, it's not even. It's nowhere near 1 mega ohm. It's like 20 ohms. Oh wait, what? Oh, now there's just nothing. We must have jiggled it too much. Yeah, so I wouldn't use that connector unless you wanted to go back through and solder wires onto it properly so it actually worked. But anyway, I think I'm gonna come in here and just add a piece of wire from that ground pad up to this thing. It's interesting that this has like a spade connector already crimped onto the end of it, but they didn't bother to hook it up to anything. These heater units probably just come out of the factory with that on it, and they had no idea how to hook that up, so they just didn't, I presume. It's one of those things where they're just cutting every corner that they can, because of course you don't need this to be grounded for it to function. So the grounding on this is absolutely pointless and completely terrible. But anyway, we'll go ahead and try to fix that at least. I'll add a wire from there to there and we'll ground out the heating element. Alright, so one little piece of green silicone wire later, I should be able to probe the ground pin and the case, and they should be connected together, which they are. So that should make this unit just a little bit safer in case the heating element wires short out. It'll just short to the ground in this, and it should pop the fuse in the back of the unit. And if you're curious, this is what the fuse looks like on the inside of this unit. It's just a standard glass fuse, so nothing too special about that. Overall, this piece of equipment for the price isn't too bad. There's a couple of things that are a little bit sketchy on it. For example, that ground wire that we found that wasn't connected at all, and also the really thin wires that are in this cable are a little bit concerning as well. But I'm going to go ahead and continue to use this thing. You definitely don't want to leave it on and leave it unattended, though. That's the only thing I would be real careful about with this thing. So anyway, that's about it for this video, and I'll see you in the next one, guys. Bye.